Several years ago in a major metropolitan city, a busy workday was in full swing. People moved through their routines, trusting their everyday mode of vertical transportation. In a complex of city-owned buildings, 2 elevator mechanics were responsible for maintaining more than 40 elevator units across 3 buildings. They rotated between locations, listening, observing, and making adjustments as needed. Elevator maintenance is a constant battle against wear and tear, with the goal of preventing shutdowns and responding quickly when they happen. A group of people gathered in the lobby. Some waited patiently, others not so much. Bing! An elevator arrived. Doors opened, passengers stepped in, and floor buttons were pressed. What they didn't realize was the complex sequence of events required to make that simple ride possible. The controller processed multiple safety and logic checks, doors closed, lock circuits engaged, the main contactor energized, and the brake released on the hoist motor, allowing movement. Decades of engineering made this everyday action seem effortless. But today, a random electrical component had reached the end of its life. A resistor failed, a fuse blew, or a critical circuit opened. The elevator stopped abruptly. Power dropped out, the safety circuit activated, and the brakes clamped down hard. A full car of passengers were now stuck between floors. Inside the car, silence followed. Stomachs dropped, breath was held. People glanced at one another. Thoughts started to race. Are we going to fall? Does anyone know where we are? Am I going to be late for my meeting? Someone pressed the emergency call button. Security, how can I help? Crackled the intercom. Elevator 6 is stuck. We're trapped. What floor? How would I know? Okay, we'll call the elevator guys. Customer service wasn't a priority in this city building. One of the elevator mechanics received the entrapment call and contacted his partner. Standard practice, they headed to the machine room. Their goal was to diagnose the controller, attempt to move the car to the nearest floor, level it, and open the doors. Always the safest method of passenger removal. This time, the failure was too severe to move the car. They went to the nearest floor and opened the hoistway door. The elevator was between floors, too high for safe exit below and too low from access from above. They reassured the occupants of their safety and returned to the machine room to prepare to drift the car. Drifting a traction elevator is extremely dangerous and should only be done by trained professionals. Without proper tools and experience, a car can move uncontrollably. They locked out and tagged out the main power. One mechanic positioned himself to manually release the brake while the other monitored the positioning system. The plan was to drift the car approximately 6 feet, then something felt really wrong. One mechanic looked down the cable chute. It should have been dark. Instead, he saw light and people climbing out of the car. Someone was removing the passengers. They dropped everything and ran down the stairs. On the 6th floor, they found the building manager and the fire department removing passengers from a car stalled between floors. A gaping shaft opening existed beneath the elevator. Firefighters were physically lifting people out, sliding them over shoulders and arms. The mechanics just stood there frozen. They had been seconds away from drifting the car, and an action that could have seriously injured or killed multiple people. Many lessons were learned after this near miss. Keeping firefighters and passengers safe during stalled elevator incidents through core training that forms the foundation of operational readiness is a must. A near miss demands reflection and change. Mistakes were made by all parties involved. Our key takeaways reinforce the need for clearly defined elevator rescue training standards and consistent application of elevator rescue safety protocols. Fire departments should have an SOP or SOG for stalled occupied elevators in accordance with fire department elevator rescue protocols, including sending firefighters to the machine room, at least 2 of them. Power must be isolated and locked out following elevator rescue safety procedures, or a firefighter must be stationed at the disconnect at all times. The fire department should request elevator mechanics and obtain an ETA before acting, as suggested by DRM's elevator rescue training guidelines. Clear communication with occupants is critical and is a core component of elevator rescue safety training. Firefighters should speak to the building management and ask for information regarding the elevator mechanic's location, and if they are on site, and request information on elevator safety features. You as a first responder must determine if a true emergency exists. Using a structured elevator rescue risk assessment based on DRM's FIIP acronym is strongly suggested. The FIIP acronym stands for Fire, Injury, Illness, Panic. Every department should follow a documented initial response procedure aligned with elevator rescue standard operating procedures and outlined within an elevator rescue training manual. Following a plan such as DRM's 11-step IRPs that are based on ASME A17.4 is the key to a safe removal. These steps can be carried out in any order with the exception of the last step. Now, before starting the 11 steps, always attempt to contact elevator mechanics and building management per elevator rescue response procedures. Now let's address the 11 steps. Obtain the lockbox key. Send 2 firefighters to the machine room equipped with radios, forcible entry tools, a lockout kit, fire extinguisher, and items necessary from DRM's elevator rescue kit. Verify which elevator is stalled. Determine the car's location. Make verbal contact and assess if a FIIP situation exists. Confirm the emergency stop is not engaged. Have the passenger push a couple of floor buttons. Ensure doors are fully closed. Activate the Phase 1 fire service. Notify passengers before attempting this. Confirm all hoistway car doors are closed. Cycle the main disconnect only once following DRM's elevator rescue safety requirements. That's the last step in the procedure. If these steps are unsuccessful, secure power using Lotto and implement a removal plan using DRM's suggested elevator rescue tools, equipment, and protocols. My passion is education. Stalled elevators prevent hidden dangers that demand elevator rescue training delivered through structured elevator rescue training programs with a predictable elevator rescue training schedule. The fire service lacks sufficient access to elevator rescue training near-me options taught by qualified elevator subject matter experts. That's why elevator mechanics are those experts and play a critical role in elevator rescue liability management and long-term elevator rescue liability protection. Build relationships, learn the language, and most importantly, you must work together. Work smart, work safe, train often, train safe.